Everyone, I'm TK. I'm one of the managers here at Yugabyte, working on the storage aspects of things. It's my pleasure to have Hari here, who's going to talk about PG cron in Yugabyte. Hari, did you want to introduce yourself and get started?
Sure, thanks, TK. Hello, everyone. I'm Krishna Sunder. I've been here at Yugabyte for more than 2.5 years now. And I'm also on the DSG team working with TK. Usually work on stuff like X cluster upgrades and stuff. And today, is an exciting one for me. It's about PG cron in YugabyteDB. And cron is an extension. We'll I think, give it another minute or so, wait for folks to join in, and then we'll get the presentation started. Okay, good. I think we can start now. So, a little bit about cron. So, again, a little bit about this talk. We are going to talk about go into the internals of what PG cron is, how it works in general in Postgres, and then also look at how what we had to do to get that to work in Yugabyte. And let's get started. So, what is PG cron? Most people would be familiar with the Unix cron, which lets you run jobs on a schedule. It's on a clock/calendar based schedule. You can run simple jobs. So PG cron is an extension built for Postgres that behaves just like the regular cron, but it lets you schedule SQL commands. And you can schedule this from within the database. That has a lot of major advantages because as a database user who doesn't have access to the machine, you can't go to the machine and run cron. And you don't want to run cron on a Unix cron on a different machine and give it credentials and stuff, right? So it's better to just connect to the database with your login credentials that you have for the DB and schedule SQL commands. And some of the very common use cases for PG cron is in Postgres, there's auto vacuum that needs to be run regularly. So you can say run auto vacuum when the workload is slow at 3 a.m. every day. This Yugabyte doesn't need this because you do our own garbage collection in the background. The other important one is Partman. Partman is a very popular partition management extension for Postgres. And the way that works is it has this cron job that runs every hour that keeps track of what partitions need to be created and dropped and stuff. And the Partman extension needs the cron extension. A simpler example would be materialized views. Right? The materialized views in Postgres are they are stale. They are like static copies, so they have to be refreshed frequently now. So you can either do it on a schedule, cron, and say run it every 4 hours, something like that. And that the easiest way to explain this is with an example here. And the first one is going to say, I want to delete all my old data on Saturday at 3:30 a.m. So I'm going to this weird syntax here in a little bit, but the SQL stuff. So the way you schedule a job is to call this cron function, which is called cron.schedule, and you tell it when to run, and then you tell it what to run. Right? And this one we're going to say delete from some table which matches certain condition, which is older than X. And this job will run at 3:30 on every Saturday. Another example for the Postgres one is the vacuum example, right? So you want to run, in this example, vacuum on a different database. So you have multiple DBs. You can schedule jobs on any database in the cluster. And this one, you want to schedule job on a database called some other database, and you want to run vacuum on it at 4 a.m. on every Sunday. Right? So we're just going to say this says run it at 4:00 on a Sunday and just run vacuum command. So
it is a little weird that we need to use select to schedule something, right? So
yeah, the functions in Postgres you have to. It doesn't have an exec like other DBs. It is a select. It also makes sort of sense because it returns a table with info. So it's like anyway, that's Postgres. So I don't want to get into that. And the syntax, the cron syntax is you have 5 positions, and you can say you can set these. Star means run at every interval of that unit. and you can say which minute you want to run at, which hour, which day of the month, and even the day of the week, right? So this is the regular Unix cron syntax, and this is confusing to me a lot of times too. I just go to like there's a bunch of websites you can go plug in the value to get the human readable format from this one. Cron tab is one example, and post PG cron has a little bit more niceness to this built in. You can schedule sub-minute jobs, and you can say run something every X seconds. So you can say, hey, I want to run something every 1 second or 4 seconds. I mean, it's good for demos. Some production use cases to it as well. This is like really useful. The other thing you can do is the dollar symbol, which goes in the month location, and that tells you to run something at the last day of the month. So if you want to run something once, because leap years and 30, 31 days for a month, the dollar lets you just say run it on the last day of the month. So before the first of the next month, so that you have some reports or whatever ready. Like I said, the jobs can be scheduled against any database in the cluster. It can run as any user. It's running a SQL command. The command needs the database and the user permissions to run as. And there's a pgcron takes care of all of the permission management to make sure that you can't run a job as a super user, only super user. It'll run as your own user privileges. It'll make sure the job, that query you run has permissions to connect to the DB and all that on the security related stuff. All of that is taken care of. You don't have to worry about it.
Hari, there's a question on the chat. So Louis is asking if the time zone is always GMT.
Right. That I believe the database default does kick in, but there is a parameter that you can set to change the time zone. And pgcron has this thing, and Yugabyte has the same support for the same parameter. So you can change it if you want to. Right. So how does pgcron work? And this is like all just Postgres, taking Yugabyte out of the picture, just regular Postgres. So you install the extension on one database. So even though you can run job on multiple DBs, the extension itself lives in one database. And this database stores the metadata or the data for the extension itself, what it needs to run. Right? And the extension, it runs within Postgres. It's not your typical functions or stuff like that. It is actually a Postgres background worker. So it means it runs a Postgres process. So you see a Postgres process for it. And this is called a pgcron launcher process. And its job is to just say, hey, what are all the jobs that are there in the system? Check the current time based on the time zone and whatnot, and see if it's ready to run the job. And when the time comes, schedule the job. Right? And the regular cron lets you schedule the job in two ways. One is via another background. Right? Just start another PG process. You can parallelism default is 5. It's again configurable. We can make it go up or down. And you can run jobs through background workers. Each of these will run one job at a time. But also a regular pgcron lets you use client sessions to run it as well. We don't use that in Yugabyte, so I'm not going to go too much into that one. But yeah, everything runs via background processes.
Hari, one clarification. You said extension is installed in one database, but for a customer, they don't need to take additional action, right? We would pre-package it for them whenever the feature is available.
How do you load the extension? Yeah, so this is a library extension. So you have to have it as a shared preloaded library, and you have to build it and bring it into Postgres. For Yugabyte, it's already pre-packaged. It's already built into the DB. So we just have to set some Yugabyte configuration flags to just say load it up. Right? Don't have to worry about building it and loading the libraries and all the other stuff. That's all taken care of in Yugabyte. So yeah, the metadata for cron. So cron has two tables. One is the job table, and this table literally just has the information about what jobs it needs to run. The other one is the job run details. A job run is an instance of a job execution. It's called a job run. So every time a job runs, we log into the job run details table to say when it ran, what time it ran, what is the output, did it succeed or fail. One thing to note about cron is by default, this second table is not truncated. So it'll just keep going. So Usually people just schedule another cron job to just like truncate this table on a weekly cadence or something. And two tables, of course, have primary keys and you have sequences for the table. I'll go into that in detail on the next slide. So the cron job table is your regular job ID, your schedule, your command, the user-friendly name, which database you want to run under, which user you want to run under. You can also mark a job as deactivated, so you don't have to remove the job, just say don't run this, right? So you can temporarily pause a job and resume a job. And yeah, it's a simple table, it just has a primary key and a trigger for cache invalidation and a unique index constraint with the sequence, right? Nothing too fancy in here. Same with the job run details. It's got its own primary keys and with the run ID, and it says what command each time it ran, because you can change the command, you can alter commands, right? And it'll tell you the return message and the status. Is it running? Is it done? Start time, end time, stuff like that. And this is an example of the job run details. I think the text here is too small. I'll give an actual demo example here later on. And go ahead. And yeah, that's about it, about how cron works, like the high level of how cron works. For what happens in Yugabyte, right? So how it's special about Yugabyte and cron. So Yugabyte is built with Postgres, built on top of Postgres, right? So we take the Postgres query layer and we package that into our YSQL query layer. And we say we get the parser, analyze, and stuff. We get more, right? We get like PG background processes, we get the postmaster process, a bunch of those stuff in as well. So we get whatever cron does in Postgres, all of that happens in Yugabyte as well. So it works the same way in Yugabyte, right? The one difference with Yugabyte and Postgres is that even though we reuse a lot of stuff, with regards to cron, is that you have multiple nodes, right? You have 3 nodes or 10 nodes or 100. And each of these is now running your Postgres layer and the Postgres process. And that's interesting with cron, right? So that's the context. And yeah, like I said, it's pre-built into Yugabyte, so you don't have to worry about building cron and packaging it. All of that is taken care of for you. And what's special about Yugabyte is that you have multiple nodes. You don't want to run jobs on every node, right? You don't want every node to keep running the same job. So we pick one node and call that as a leader, cron leader node. And only this node is going to execute your jobs. What that node is, where it runs, all of that is transparent to the user, so you don't have to worry about who this leader is. It's all taken care of. And you can schedule jobs through connecting to any node, so you don't have to go to the leader node or anything. Just like log into, connect to any Yugabyte node, schedule a job, and just run. And the jobs themselves, even though they're running on a single node, the queries will take advantage of all the resources in the cluster, right? Because Yugabyte's query parser layer and everything, we'll get a distributed plan, we'll do distributed execution of the queries themselves. So you will use all the resources across the cluster. So it doesn't really matter which node it runs on. And the other important thing is this leader node, what happens if this node goes down? Well, we will automatically pick a new node and assign that as the leader. So it's always going to be highly available. There will always be some leader in the system. So you don't have to worry about that. Right? So I'll go into a demo and see how this all works. And we've talked a lot. And to set up, this is my setup. To enable your cron in Yugabyte, the feature is currently in technical preview. And so to protect accidental usages from people turning it on, we have to set a G flag and this enable PG cron flag. And as a double protection, you have to also say it's a preview feature, so enable my preview feature, right? And once I set these two things, one of the common other configs that you'll set is the database that you want to install the extension in. So that is configured with this YSQL cron database name flag. The default is Yugabyte. I'm just going to let it be Yugabyte for this demo. And that's about it. And then you can just go run. It's available in master and 2.23, which is going to come up really soon. Really soon. So let's see my demo.
One quick question on the previous slide. Like, what's the significance of the database name? Is there any implication on features like backups? Like, would it get backed up if that database gets backed up and things like that? Like, what's the big significance about the database?
Right. And this is again nothing specific to Gigabyte. pgcron is the same cron database name config. And the reason is that since to schedule jobs, you have to have access to the cron DB to be able to connect to it and run the cron schedule function, right? So, it's installed on one database. So it's usually better to have it on a different DB so that every user can log into this database, even though your actual workload data may be spread across different databases, you have user access controls, right? So that's one reason to have cron metadata stored in a separate DB. And it's backed up. If you back up the database, you're going to get the jobs with the backup. If you restore, you're going to get the jobs back. So depending on how you want your backup schedules and stuff, you may want it in the same DB or different DB. It's totally up to you. If your system has only one DB, then you're going to put it all in one database. Or if you have several, you could think of moving cron to its own DB. It's totally up to the user. But yeah, you need to run jobs. You have to be able to connect to the database and you have to have permissions to run the schedule function. So that's one of the main motives, to have an option to change the DB.
Got it. There are a couple more questions on chat.
Okay.
It's related to multi-region clusters. So Juan says, if I have a multi-region cluster with read replicas and want the job to be scheduled in a specific region or a specific zone, is there a knob that we provide today, right?
Right. For the most part, it shouldn't really matter because jobs are running async, and most of these jobs, like I said, the queries are fanning out. So it shouldn't really matter which node the job is running from. Most of these jobs are doing simple DDLs and simple, even truncated DDL, right, statements. It's not resource intensive assets, so it should not really matter where it runs. But there are some advanced ways to, like, I'm not going to go into that in this thing. But if you want, we can pin it. We can pin the leader to a zone and say, hey, if you're multi-zone, I want my cron leader to be on this one. And Yugabyte lets you pin tables and databases. So you can use the same way to pin stuff. It's a little bit more advanced right now. There's no YSQL way of doing it. So I'm not covering it here. But yeah, if you're an advanced user and if you want to do all of that, you can definitely do it.
Right. Actually, related to that, I think Jim also had the same question. Can we control where the pgcron leader resides via table spaces, right? Especially on geopartition databases, we might want to run the cron jobs only in a specific geolocation, right? So, yeah.
Yep. Yeah, that's again nice feedback. Like because like, right now we assume it's an advanced thing, so it's like not, you can do it, but you need to run some extra commands outside of SQL. But yeah, if folks want it, it's in tech preview. That's why it's in tech preview. Right. You can definitely bundle it into a SQL command, right? Yep, definitely possible. So my setup, yeah, this setup is a simple one. I just have it on my machine. It's a 3-node cluster. Everything's on one zone. It's just like dummy one, but it could be geo-partitioned if you want. And I have 3 masters and 3 tablet servers to keep it simple. And let's see. So I'm gonna YugabyteDB. It's just all running on YugabyteDB. So I'm just gonna create my extension. So my G flags are configured, so I'm not showing that here, but it's already set up. I'm just gonna go ahead and run create extension pgcron. And once my cron extension is up, I'm just gonna schedule a few jobs. So the first job I'm gonna do is gonna run every 1 second. I'm just gonna get my job, right? And it's inserting into a table just some value, just a dummy one. It runs every 1 second. And to make it a little bit more interesting, I'm going to have another job, which is actually going to drop. Let me schedule that as well, and I'll show you what this does. So this job calls this function. So I'm going to schedule a job that says drop all tables. That's my job. And what it does, it's just going to find tables based on names, and it's just going to delete tables with the oldest name. Right? I'm going to keep 5 new ones. Just some fancy DDLs. Just say I can dummy either a DML or a DDL from cron. Right? So now that I have these 2 jobs, oh yeah, this thing inserts into a table. I need a table. Let's go and create the table. And I'm going to have a default time so that I know when the job ran. Right? I don't have to go to cron. I have to get my table and see when it ran. So let's see my jobs. Select job from cron.job. Right? And this is the cron job table. Right? So you can see my 2 jobs here. This job, which is going to run every 1 second, that's the command it's going to run. and the other one, which is going to run the function, drop all tables, and this both are active right now. Both are running against YugabyteDB, right? And to see the job runs, when did the job run, I can do select star from cron job run details. And there you go. That's a lot of runs, 1 second, right? So it's running a lot. So you can see my, what's that? Insert job running and the drop all tables job running. Both are running. Of course, one is running 3 times more than the other one. So if I go look at my table now, I found this to be an interesting way to see the job actually run. I'll just do a top 10 for my table, right? And you can see the insert time. It's running every 1 second. So I do a top 10 for my table. If I can just watch it every second, I'll see that there's a new row getting inserted every second in my table. So that's a cron job running. Right? And same for the DDL one. To get the DDL one, I'm just going to create some dummy tables. And the job is going to drop all tables with prefix TBL name. So if I now create a 6, which is the 6th table, it should drop table 1. Right, so my tables in 3 seconds, it should just drop table 1, and there you go, table 1 is gone. If I create more tables, it's going to drop the old table. So it's just like keeping my table count in sync, right? You can imagine the same for partitions. So which is why partman is going to use this to drop all partitions. And /t, my old table / partitions are gone by cron. And yeah, a quick demo, but what's going on here? So it's going to run in one of these 3 nodes. Which node? I don't really have to care. I'm just connected to one node. I run my job. It's all transparent to me. It's all just run. So what's going on under the covers, though, right? So this is like under the hood in Yugabyte. So like I said, there's a leader node, and one of these nodes. So every node is running PG. Every Yugabyte node is running Postgres. So if I look at my PS, it's going to say a bunch of Postgres processes. And everyone is going to load the library and load PG cron launcher. So in Yugabyte, though, the launcher runs in a passive mode. As soon as it starts up, it says, I'm not going to do anything. And it's going to wait for someone to say release on it. So once the launcher gets valid release, it becomes active and says, I'm now a leader. Let me go find the jobs to run jobs. And as if I lose the lease, I'll not run jobs. And the DB makes sure to set the lease on one node and one node only. And if the node holding the lease, if it goes down, if it crashes, or if it just gets network partitioned and all of that stuff, it'll reassign the lease to another node and it'll make sure the old lease expires, right? And so it'll make sure there's only one leader node, cron launcher node active in the system. And this even more under the covers is done yeah, questions?
Sorry, this is great, right? Like in the sense that Yugabyte is a highly available database and the value-added services like PG cron also are highly available, right?
Highly available.
So always have it. It's pretty good, yeah.
You don't want the job to just stop running because a node went down.
Right.
And upgrades and stuff, there's always new node happening, things going down. So there's always stuff going on. So you don't want the jobs to stop running. With regular Postgres, you have to take PG down during an upgrade and then bring it back up. So whatever jobs have to run during the upgrade window, which may be 15, 30 minutes, right, those jobs will never run, and because it's unavailable. It's an outage during upgrade. With Yugabyte, all of that problems don't exist anymore. And a little bit more, we're already under the hood, but a little bit more under the hood is this stateful service thing that we have in Yugabyte. So it's this highly available service that's within the DB that's like sort of like a microservice-y thing. I'm not calling it a microservice, but it's highly available. It's one leader on one node at any time. It's built using Raft, which makes sure that it's highly available. It's got a leader and all of that stuff. And we use that to set the cron lease. Right? It's used for cron. It's also used for another feature coming up with the auto-analyze. Sneak peek there is we are using all of these fancy stuff to say, hey, run special things within the DB. Right? And I can go see where is the advanced stuff of where is it running. Now that it's running, but where is it running? How do I change it, right? So you can go see it. You can go to this UI page here to see stateful service, and I can see my job is actually running from node 3, top 3. And it's got this service. I can pin the service. I can say, hey, pin it to a particular region or a zone and all of that fun stuff. And by the way, my demo is actually connected to the .1 because it's connected to the first node. By default, I just go to .1. So it's connected to a different node and running from a different node. So, yep, there's a link to the doc. You can go take the latest master and build it if you want and try it out for yourself. They're like very happy to get feedback. It'll be available, like I said, in the next 2.23 release, which will come up really shortly. And yeah, do you have any questions?
Yeah, I don't see any questions yet on LinkedIn yet, but we'll probably wait for a couple more minutes for folks to.
And always feel free to post on Slack. We'll be more than happy to answer your questions for you.